an error. In this diagram, each orange particle has a mass of what? 4 grams. So this is each circle or each particle has a mass of 4 grams. Wait. Look. Particle is 4 grams. Okay.
أستاذ ده ما حكيت اسم سلمى صح على
Salma, where are you? طيب. And this one is 4. And this one is also 4. Sorry. استنى شوي. Okay. And this one is 4. So what is the total mass of iron atoms? It will be
16
16. المرة الماضية لما حليناها شو كتبناها انها انه 4.
4
sorry. So this is 16 what? Grams. 16 grams. Understood? طيب. Let's continue. And each red particle, by the way, these are the iron atoms. The total mass of iron atom is 16 grams. What about the oxygen atoms? Each particle or each red particle, each red particle has a mass of what? 1 gram. So each one of them is 1. So what is the total mass of the oxygen atoms? 1, 2, 3, 4, 5, 6. So it is
6
grams. طيب. Now let's calculate the mass of the rust. The rust is made up of oxygen, of iron,
22
iron and oxygen. So it is 16 plus 6 will be
equal 22
22 grams.
grams.
So in a chemical or in a physical change, طيب, is this a chemical change? Is this process a chemical change or physical change?
Physical change.
What?
Physical.
No,
Or the chemical.
it's a chemical change because
Chemical.
two substances combine with each other to form one new substance. طيب, notice that.
This is resting, right?
استنى شوي. Okay, notice that the total mass of the substances before and after the change remains the same, and this is the law of conservation of mass. Law of conservation of mass states that in any physical or chemical change, mass is never created or destroyed, or the total mass remains the same. Okay, so here we have iron or steel and oxygen. They combine with each other to form rust. This is a chemical change. Notice that the total mass remains the same. We have 22. We have 22 grams of substances, and here we have 22 grams. So the mass does not change. Okay. So the law of conservation of mass or the law of conservation of matter states that in any physical or chemical change, the total mass remains the same. Okay. In any, this is the law of conservation of matter or the law of conservation of mass, states that in any chemical change or physical change, the total mass of matter does not change. Okay, This is simply what we mean by the law of conservation of matter or law of conservation of mass. Also, sometimes the chemical change is called a chemical reaction. Okay, طيب. Look at turn to page 70 and 71. 70 and 71. The question is matter conserved? Of course, we know that the answer is yes. Is matter conserved? Yes, that's right. Matter is conserved. But here, it's another evidence or another example of how matter is conserved in chemical and physical changes. Let's see this example or this evidence. Right. Read the information for each step to see what happens. Okay? Read. خليني أعمل erase لهنا والله شو erase. طيب again. Read the information for each step to see what happens during the chemical reaction or a chemical change. Write a math equation to model how the masses of the original substances and the new substances compare. But let's see what we have here. طيب, look here. What do we see here? Substance A. This is a substance A. What is the mass of substance A? It is 180 grams. The mass of substance B is 90 grams. طيب. Each flask, this is called a flask. Wait. This bottle is called a flask. Look at this is step 1. We have substance A and substance B. The mass of substance A is 180 grams and the mass of substance B is 90 grams. Each flask, this is called a flask and this is a flask, holds a different substance. Look, this is the substance A, it's different from substance B. Read the mass on each scale. We read, okay. The mass seen on each scale is the mass of the substance. The mass of the flask has been subtracted. So this is, for example, when we say 180 grams, it is the mass of the substance A without the flask. 90 grams, it is the mass of the substance B without the flask, because the mass of the flask has been subtracted. Okay, then what happens then? Where is step 2? Please wait. Where is step 2? Okay, step 2. Okay, this is step 2. Notice that in step 2, we mix, or the two substance A and substance B react with each other. They form two new substances. The color of the liquid substance is different from the colors of substance A and B. Notice that substance A is green and this is red. And when a chemical change happens, we have two new substances with different colors. Okay, the color of the liquid substance is different from the colors of substances A and B. A new solid substance is visible. Look here, this is a new substance. It is solid, it is visible. 2. These observations provide evidence of a chemical change. So a chemical change happens. A chemical change happens. 5. Now, write the total mass of the two new substances. Ignore the mass of the beaker. Again, you have to ignore the mass of the flask. hint use information in step 1. طيب الآن بعطيكم فرصة تجاوبوا. مين بيقدر يجاوب؟ شو بتتوقعوا الماس راح تطلع؟ شباب هون.
Can I?
استنى
Repeat the question.
Raise your hands. Raise your hands. What do you expect the mass? Hassan.
The mass is 100.
Mass
98.
118.
198.
Okay, the mass will be, please write the answer. The mass will be
198.
excellent. 198 grams. Okay, this is the answer for this section. So the mass will be 98 grams because it is the total mass of A and B. Okay. I forget هاي step 2 طلعت عندي هون عفوا بس just to remind you that we mixed A and B. After we mix them, a chemical change happens and we have a new mixture, or not mixture, when substance A and B combine with each other, a chemical change happens and the total mass is 198. طيب طيب when substances A and B are poured together they mix. Okay, طيب نرجع back to this page. يلا خلينا نعمل erase أول شيء. يلا can you write the equation؟ يلا شباب مين بيقدر يحكي لي الايكويشن هون؟
Can I?
طلع again. Read the information for
108.
Can repeat the question?
wait ملك. خلينا نرجع من أول again. This question or this exercise, let's see that this is an example or an exercise of how matter is conserved in a chemical change. The question is matter conserved? Yes, of course. Matter is conserved because according to the law of conservation of matter, mass is never created or destroyed, or the total mass before and after the chemical change remains the same. So the answer is yes. But here, this is an evidence or another example. Here we have two substances, A and B. Okay? Again, here we have two substances, A and B. The mass of substance A is 100 grams without the mass of the flask. The mass of the flask is subtracted. The mass of substance B is 90 grams. Again, each flask holds a different substance. Read the mass on each scale. We already, this is 180 grams and this is 90. The mass seen on each scale is the mass of the substances. The mass of the flask has been subtracted. After.
It's 108, not 180.
Okay, wait. ايش حكيتي؟
108 and 100.
108, not 180.
108. This one is 108, and this one is 90, not 180.
You said 180.
sorry. مرات بغلط بكون مش مركز. Okay. I'm sorry. Thank you. ملك اللي حكت؟
Yeah.
Thank you very much. Sorry, again, this is 180 grams, not 180, and this is 90 grams. What happens then? In step 2, substances A and B are mixed together. When substances A and B are poured together, they mix. Then a chemical change happens. The total mass of the new substances, look, when we mix A and B, what happens? A new substances, there are two new substances formed. One of them is solid, okay? the total mass, we solved it. When write the total mass of the two new substances, it is 108 plus 90, which is equal to 198. Get it? Right. Back to the first question. Now read the information for each step to see what happens during the chemical reaction. Okay. Write a math equation to model how the masses of the original substances and the new substances compare. What is the equation? Can you write? شو رأيكم? It's very simple.
عليهم
No.
أحسن بالنسبة لي.
طيب شو رأيكم?
راني أصدقي.
Can you write
لا.
the equation?
Yes.
Okay,
106
look,
plus
write a math equation to model how the masses of the original substances and the new substances.
108 plus 90.
Okay, what is the masses of the original substances? 108
108
plus,
and 90.
which is equal to?
190.
That's it.
98.
Grams here and here grams.
أستاذ راي.
Yes, write it. This is the answer.
Yep.
So, what can we conclude? That in a chemical change or a physical change, the masses of the original substances is equal to the masses of the new substances. And this is the meaning of conservation of matter. Please, did you watch the video from YouTube about conservation of matter?
Yes.
It's very simple. Did you notice that that the total mass remains the same?
Yeah.
In the experiment, did you watch the video?
Mr. Which video?
I think I sent 2 videos.
Yes.
Right.
Mister, before the exam,
نعم.
before the quiz,
Yes.
ماله الكويز؟
before it,
مش فاهم عليك ايش يعني؟
يعني الفيديو اللي
before the quiz,
لا لا مالك these videos to support you حتى تفهموا أكثر.
the videos was before the quiz.
لا, I think I sent them on Thursday after the quiz. I don't remember exactly, but I sent them on the group.
Yeah, I know.
طيب.
مثمرة.
طيب, can we continue?
Yes.
Yeah.
طيب, please listen to me. Another examples of chemical changes. List, okay. Examples of chemical changes. طيب. Okay. Chemical changes happen in the kitchen all the time. In your kitchen, you can find or you can notice chemical changes. A chemical change occurs when a chef makes fresh cheese. To make fresh cheese, the chef adds lemon juice to whole milk. Once the two liquid ingredients are mixed, solid pieces start to form. This is an example of a chemical change in the kitchen. When a chef or adds lemon juice to lemon juice to whole milk, when they mix, we have a new substance with different properties. This is a chemical change. The solid pieces called curds are chunks of fresh cheese. They form as a result of chemical change. To prepare the cheese to eat, the chef separates the curd from the liquid. So this is just an example of a chemical change. Also, there are other chemical changes in the kitchen, like making a pizza, also baking a cake, baking a bread. All of these are chemical changes that happen in the kitchen. طيب. Different kinds of cheese are produced by further, sorry. وين صرنا؟ طيب. Different kinds of cheese are produced by further processing of the curds. For example, to make soft, stringy cheese like mozzarella, تعرفوها هاي الجبنة? The curds are needed. Anyway, these are examples. Okay, it doesn't matter. يعني, just these are examples of chemical changes in the kitchen. يعني making cheese is an example of a chemical change. Look, these are the steps of the cheese. How it's a chemical change. Okay, طيب. Let's read the next page. You may have, sorry, another example of chemical changes. You may have noticed another chemical change over time. Some pennies change color from copper to green. Look, this is a penny. Okay. Look, its original color, and look what happens to this penny. It's a chemical change. This coin or this penny is made up of what? Copper. Copper is a metal. Okay, over time, some pennies change color from copper to green. To green. Look how this color change happens because of a chemical change. This is a chemical change. The copper metal that makes up a penny combines with oxygen in the air to form a green substance. So why? What happens to this penny? This penny is made up of copper. Look at the original penny. It's now here in this, here it is new. But over time, over hundreds of years or over a long period of time, a chemical change happens to this penny. It combines with oxygen in the air. The metal copper that, or the penny is made up of copper. The copper in this penny combines with oxygen in the air to form a green substance. This green substance, it's a new substance, is called copper oxide. It is called copper oxide. Look here, what two substances, the question is, what two substances is copper oxide made of? This is copper oxide. It is made up of two substances. What are they? I will give you the chance to answer. But please raise your hands. No one answer without permission. Yeah.
يلا.
No one answer without
Mr.
permission.
Me, Mr. Me.
Who's talking?
يلا مين؟
Me, teacher.
Kala?
Sadine.
No, me.
Sadine. Okay. Sadine. Sadine, you can answer.
Copper and oxygen.
Me.
Copper and
Muhammad
oxygen.
Copper and oxygen. Are you agree with Sadine?
Can I?
Okay. Who's talking?
Yes.
The copper and oxygen.
Copper and oxygen. Thank you very much, all. So these two. Wait. Please wait. Wait. Copper. What two substances is copper oxide made of? The answer is
Copper and oxygen.
copper. And please write copper and oxygen. Okay?
And oxygen.
Thank you. So when copper and oxygen combine, copper in this penny combined with oxygen in the air over a long period of time, a chemical change happens or takes place and copper oxide form. How do we know? How do we know that this is a chemical change or this is a copper oxide? By the color. By the way, inshallah, in grade 6, we will talk about chemical changes in more details. Chemical changes in general, there are indications, there are evidence. Oh, please listen. Wait.
Mister, I didn't understand.
Wait, who's talking?
Sarah.
Okay, Sarah, I will repeat. طيب. طيب. We are talking about this lesson. Let's back to the first of at the beginning of this lesson. The title of this lesson, lesson 3, is chemical changes. We mentioned that any type of matter, any matter can change. These changes can be classified into two types: physical changes and chemical changes. Physical changes do not affect or do not change the matter into something else. In a physical change, we don't have a new substance. In a chemical change, we have a new substance with different properties. I mean, in a chemical change, it's a change that produces one or more new substances. In a chemical change, the original substance or the original substances changes to new substances. For example, this coal or this charcoal burns. Burning is a chemical change. When charcoal burns, a chemical change happens and the charcoal changes to new substances, to ash and gases, to ash and gas. Look, when charcoal burns, a chemical change occurs in which charcoal and oxygen in the air combine with each other to form new substances. These new substances are ashes and gases. Okay, there are a lot of chemical changes in the nature. There are many examples of chemical changes. For example, when you bake a cake or bake a bread, this is an example of chemical change. Also, rusting, for example, rust is an example also of a chemical change. In a chemical change, you have to know that the total mass of substances that undergo chemical changes remains the same. The total mass of substances before and after the chemical change remains the same. This is according to what? To the law of conservation of matter. The law of conservation of matter states that in any chemical change or physical change, the total mass of the matter does not change. So here, for example, the total mass of substances of iron and oxygen before the change is 22 grams. Rust, the new substance rust, has the same mass, 22 grams. Okay, this is the meaning of the law of conservation of mass. Okay, today we just take another examples for a chemical change and how is matter conserved in a chemical change, and we say that, for example, substance A and substance B, the total mass of them is 198. When they mix together and form new substances, the total mass of the new substances was 190 grams, 198, sorry. So the total mass remains the same. Here, in this example again, we have another example of chemical change. In this chemical change, this penny is made up of copper. Look, this is a new penny. It's original penny. After a long period of time or over time, this penny changed to green color. Why? Because a chemical change happens. Here, sorry, in this example, there are two substances mixed. The copper, this penny is made up of copper. Okay. Over time, copper in this penny combined with oxygen in the air. Okay. Combined with oxygen in the air to form this substance called copper oxide. The green color of this penny, why this color? What happens to this penny? It becomes green. The green color of this penny is because of copper oxide. This is the color of copper oxide. This copper oxide is a new substance, changes the color of this penny. Look, the difference. So the copper oxide is made up of two substances, copper and oxygen. Copper and oxygen. When copper in this penny reacts or combines with oxygen in the air, a new substance called copper oxide. This is a chemical change. Right. Let's do the second exercise. Do you think the old penny will have the same mass as the new penny? Explain your reasoning. What do you think? طيب. What do you think? Do you think the old penny will have the same mass as the new penny? Explain your reasoning. طيب. Okay. Who can answer? Raise your hand.
Mr.
Tala. Listen to Tala. Okay.
Mr. Can I?
Can I answer?
يلا Tala, listen to Tala.
No.
Repeat the question.
No, because it combines with oxygen.
Yes, the
The
same.
same.
Gives it more mass.
Yes.
Excellent. So the new penny, the mass of the new penny is sorry, of this penny. Okay. The old penny will have a greater mass than the old, because some of the copper has reacted with oxygen to form copper oxide. Okay. So in this case, يعني, in another word, the mass of the old penny will equal to the mass of the original penny plus the copper oxide. Again, the mass of the old penny will equal to the mass of the original penny plus what? Plus copper oxide. Again.
Teacher.
Wait.
Okay.
The mass of the old penny. Don't write anything. I will send you the answer. But just the mass of the old penny, sorry, will equal to what? The mass of the original penny plus what? Plus what? Plus what?
Plus oxygen.
Copper oxide. Okay, or yes, plus oxygen. Yes, because it reacted with oxygen. Okay, but if you, for example,
Mr. Yusuf.
wait استنى شوي راح اعطيك الشانس كمان مره خلينا نحكي استنى شوي. يعني in this is a chemical change. You have to know the original. If we add the mass of the original penny plus the oxygen that it reacts, okay, as we mentioned that the original penny reacts with oxygen, and